Welcome back, guys. Today we're going to be dealing on mostly calculations. Okay, so remember on our last video we're discussing about some basic laws under ideal gases, and in fact the study of gases. I talk about the Charles law, the Boyle's law, and the ideal gas, and the Gay-Lussac's laws and stuff. Okay, today we're going to be discussing more on calculation under gases. Now, under the study of gases, your parameters given to you tells you what law that question is coming from. Now, if you take a look at this question up here, you can quickly tell, okay, this is where it is coming from, if it is Charles law, Boyle's law, ideal gas law, and stuff. Now, let's read this question. The question says a sample of an ideal gas consists of 0.176 mole and occupies 8.64 liters at a pressure of 0.32 atm. Now, what is the temperature of the gas in degrees Celsius? Now, what does it tell you? Although you can't get this from the write up here, you can only get it when you write up your parameters. Okay, so now let's write out our parameters given. Now I say a sample of an ideal gas consists of 0.0176 moles. So the number of mole is 0.176. Now, and occupies 8.64 liters. Now, the volume is 8.64 liters. And remember, our volume can either be in liters or in dm cube. So assuming it was given here in dm cube, it doesn't change anything. You shouldn't convert. You can leave it on dm cube or liters. Now, at a pressure of 0.432 atm, pressure to be 0.432 atm. Now they're asking for the temperature. What they specified is here in degrees Celsius. Now take a look at these parameters here. What does these parameters call for? Is it the Charles law, the Boyle's law, or the ideal gas law? Now, under Charles law, we're discussing that the volume of a fixed mass of gas is directly proportional to temperature. Then for Boyle's law, it said the volume of a fixed mass of gas is inversely proportional to its pressure. Now, then for ideal gas, we have that PV is equal to nRT. So from here now we have that V1 over T1 is equal to V2 over T2. Then here we have P1 V1 is equal to P2 V2. So now take a look at this one, this first one, the second, and the third. Which of these relates to these parameters we have here? So now we have here volume is here. We have temperature is here. So if we ask for moles, mole is nowhere to be found here. So this equation is not allowed for these parameters. Now let's go for the other. We have here that pressure is given here, temperature is given here. Then let's ask for moles. Mole is nowhere to be found here. That's for the second. Let's go for the third. Pressure is here. Then volume is also here. Then the number of moles is given here. Then the temperature is given here. So now this should tell us that this ideal gas formula should go for this question. Although our rate here, our constant here is not given, so you should always know if you are not given if you're not given the constant for the rate, look at the parameters given. You will know if it is 8.314 or 0.0821. Now, looking at these parameters we have here, this should be the right unit or the right value for our rates here. So now, let's proceed. Our PV is equal to nRT. Now, our pressure here is atm, so we have it at 0.432. Then our volume is in liters, so we don't have any converter to do there. So we have 8.64 is equal to the moles. We have the mole to be 0.176 times arrow to be 0.0821, and times the temperature, which is unknown. Now let's multiply this. We have here to be 3.73248 approximately. Then let's multiply what we have here. So we have here to be 0.01445 T, because we're multiplying the T here. So let's divide both sides by what we have here. So our temperature will be 258.31 approximately. This is our temperature in Kelvin. Now, looking at the question we have here, they said, what is the temperature of the gas in degrees Celsius? So now we're not leaving it in Kelvin, but rather in degrees Celsius. So now let's convert our temperature to degrees Celsius. So now we have that. Remember, I told you on our last class that to convert your Celsius to Kelvin, you have to add 273 to it. Now, we're not converting from Kelvin to Celsius. So what do? We have to collect like term to make degrees Celsius to be units. So now let's make it units. So we have degrees Celsius will be equal to Kelvin temperature minus 273. So what is our value of Kelvin here? We have it to be 258.31 minus 273. So what should our value be? This should give us an approximate value of negative 14.7 degrees Celsius. Although this should be your answer to this question. Now, if on your options you didn't see 14.7 degrees Celsius and there is no none of the above on the options, listen to what I'm saying. If this is your answer you got, you solved it correctly, and on your options there was none of the above, and you had 15 on your options, you should quickly approximate your value. This is 14.7, this is above 5, so we have it to be collect like term to the nearest whole number. Our value will be minus 15 degrees Celsius. So if there is none of the above on your option, but you have 15 there, click 15. But if your answer is 14.7 and they didn't give you any indication to approximate to the nearest whole number on your answer, and there is none of the above on your option, click none of the above, because 14.7 is different from 15. they are a whole different value. So if there's none of the above and they didn't give you any indication to approximate to the nearest whole number, click none of the above. Thank you.